Welcome to Unnecessary Computer Things. Today we're looking at Commodore 128 graphics and also some interesting optimizations and timings that I've looked at with Commodore Basic. If you program in modern programming languages, you'll be somewhat used to being able to use more than two characters with for variables and things. Um, some 8-bit computers have basics that will allow you to use up to 5 characters before it starts complaining. And so the first example I have here is a cosine wave version that actually uses these 5-character variable names. So when we run this, it takes a little bit of time here. I think it's a little over 48 seconds, almost 49 seconds. It's calculating 2 points per step, so 640 points, but the actual screen's only 640 or 320 by 200. This is to make it consistent with the max resolution on an 80 column by 25 row display, like 80 column mode on the 128 will do. So I actually have a little bit of a pause right here to just kind of see what you have. And it's 48.75 seconds. Now, if you look back here, I used as many characters as possible to hopefully be able to track what these variable names mean. I also have some rem statements for comments. Those actually have a bearing as well. So if I actually go in and first I'm going to go in and chop those characters down, those variable names, to 2 characters, and I have this in VS Code, and I have each step along the way in the GitHub repository. They'll be linked, so you can look at it, play with it, and yell at things that I missed here. But so I've reduced the variable names down to 2 characters each, but I've left the comments in there, and if you can notice, one is on the for statement, but then one is inside the loop as well. So this does actually have a meaningful difference. You can't notice it while it's running here, but you will see once this actually completes. So the original was like 48.75 seconds. This one is going to complete a little bit faster, and that gives some indication that the parser for basic is actually doing extra work there to process those extra characters. So again, I have a 5-second pause at the end of this. 48.08 seconds. So next fun exercise we're going to do is take, and I could edit this, but that would involve capturing the process of typing. And I have an end there that's unnecessary, but for other versions of this program, there are subroutines to help draw, so I just left them in there for this. So I think the REM statements themselves actually contribute a few seconds of processing every loop. So obviously, since you don't have a compiled language, it's going to interpret it along the way. You can actually edit the basic code in memory, and it will change the course of action while it's running. So it is interpreting those basic memory locations every time through. We're almost done here, so and then the nice pause to enjoy this graph that you've seen 3 times already, twice already. So it's 45.35 seconds now. So those REM statements contributed almost 3 seconds of processing time. So I'm going back. This code actually has comments back in it, mainly when I was reducing them to character, I had to actually keep track. One extra optimization I've done is I've actually flipped the Y scale, so it's actually doing that calculation. So one fewer multiplication in here. And if you run this, you might actually be able to tell that this one is running faster than the others. And the difference was that I've factored out a -1 out of source code. I also, it's not all of that. There's also an int conversion for the x and y coordinates. So I will just paste. So before, we had these 2 lines, and this isn't the int conversion isn't necessary for the draw commands in BASIC, but if you are poking memory locations and figuring out the memory locations based on the x and y values, and you have a fractional value, then you're going to end up potentially going to a new row. So that was an artifact of the benchmark that I did for the 8 column mode. But the new code eliminates this, the line 1110, and then changes line 1100 to have that times -1 factored out. So, but these int conversions are probably the heavier operation, but it's 36 seconds now. And then one last optimization you can do, since I have all those comments. We're 36.28 seconds right now. You can see with the final run without any of the comments that it will run a little bit faster. So now, yes, 31 seconds instead of 36, or 35 seconds instead of 36 seconds. one last attempt, and I don't know that this matters, but taking out the spaces, I haven't tried this before, so I hope I don't run into syntax errors, but no, it works. So I actually removed all the embedded spaces in the code after the line numbers. And we will see if that improved it any more. It was, 35.13 seconds before. So now, see. Okay, and get the sleep delay at the end. So it was 35.13 and now it's 35.1, so 300ths of a second. The emulator doesn't 100% get the same result every single time, but it is within a few hundredths of a second, but this is probably as much a potential rounding error at this point. But so yeah, that's one of those things I've been playing around with, just kind of observing like how the interpreter works and how the optimizations go, and how much refactoring your code and BASIC changes the performance, whereas on much faster machines, those numerical operations you wouldn't necessarily optimize those out, because they would, I mean, if you're looking at this in some modern code, you would scratch your head, because these variable names are somewhat unintelligible, and there's no spacing, there's none of that. But for this era, and certainly if you're programming in BASIC versus programming in assembler on the 6502 or 8502 for the Commodore 128, it definitely does matter how much you optimize your code. So and the variable names are one thing, but also just order you do a bunch of these operations, you would probably in many cases either factor it out into a separate subroutine function, or you would actually put the whole calculation together, because having these intermediate steps optimized out already makes it a little bit harder to understand what's going on with the code. But it did take it from worst case with 48 seconds with 48.75 seconds with comments. The 5-character variable names too in there, which I don't recall. I'd have to dig into the programmer's guide whether those are actually officially supported or just kind of they're tolerated. It seems like most of the platforms that I've looked at so far, they're tolerated. If you name something like Y05, let's say, and I forget that the enter key is in a different place, or the equals key is in a different place on this. So if you're doing this on a newer interpreter or anything, or newer compiler, newer language, you'd expect X04 to be 5, which it is, but then you would expect X05 to be 3, and it's not, because all it cares about, and it's actually XO, all it cares about is the XO part, and not the 5. So it stops interpreting variable names at the first 2 characters. Well, that's all I had for today. I just kind of wanted to walk through the yak shaving that I have been doing with playing around with a basic interpreter and Commodore 128, and hope you found this at least somewhat interesting in terms of how the inner workings of the interpreter worked in terms of performance. And I'll see you next time. Thanks.